All right, a little bit about myself. I am the CTO at RavenPack, but I'm also a hands-on developer and do common Lisp programming, actually, which is a big part of what we're doing. We're also using Java and Python, and if you find all this interesting, please stop by our booth, and we're hiring. Perfect. So what is RavenPack? Because I think it's really important to give some context to what I'm going to be presenting here about migrating to the cloud. Why are we doing that? What is the business that RavenPack is in? What problems are we solving? So there are some buzzwords here, but I'll try and explain what we do. We deliver big data analytics to financial institutions. Okay? So that is stuff that their computers can use. Okay? Top hedge funds and investment banks use RavenPack data to help their trading, to make more money, or to help manage risk, and also for compliance. If someone trades before the news happened, that could be insider trading, and you're out of compliance. We have patented technology, and sorry about that. More importantly, the patented the research that we present. A lot of our data is new to our customers that are using it, that are used to looking at stock prices, bids and asks, market depth. When they get a new data set, they also want research about how to use it. So RavenPack really sells a full solution, the data and then examples of how to use it. Okay. And we have an archive of more than 300 million documents spanning 20 years. So quickly, we can say that RavenPack is processing hundreds of thousands of documents every day in real time. Okay. We're producing machine-readable information from unstructured news stories like published by Dow Jones, published blogs on the web, news stories, anything like that that you see on CNN, whatever. That's unstructured, becomes structured. And the expected processing time for any document is about 250 milliseconds. So it's kind of big data in terms of published news, and it's in real time, and our clients are benefiting from it today. So in this talk, I want to explain a little bit about what classification is, because we'll be talking about how we migrated classification from a non-cloud system to a cloud system. So it will help to understand that. We migrated that in a real-time sense, and also this historical archive. So we'll look at those two cases, talk about some of the problems associated with migrating to the cloud, although there's lots of benefits. What were the challenges? What's new and interesting? And then we can look at some new possibilities, some new things that RavenPack is going to be doing that become either a lot easier or were simply almost impossible before using a cloud type of architecture. So classification, generally speaking, when we talk about classification at RavenPack, it's extracting meaning from unstructured text. As I mentioned, unstructured text is a news story. You read them all the time when you go to, any news websites, and professional people are subscribed to things like Dow Jones Newswires, where they get it straight away without having to scrape the web, things like that. RavenPack also receives that type of information. Okay. What we do, of course, are things like tokenization, which at one hand is very, very simple, right? It's just kind of splitting documents into paragraphs and words, things like that. This is really easy, of course, with a computer language. You have a spec that says a name is some characters and underscores and digits, and that's fine. But when you're talking about news or human text, you need to understand that tokenization matters. If you see the digit 3 and the letter M next to each other, you could say, well, that's like 3M, the company. Let that be a single token. Well, except in a lot of stories, that might be 3 million, or it might be 3 months. So your tokenization has to know that you want to split those things apart, right? Things that if you don't do them right, they're really hard to fix later on. Right? Once you've got things tokenized, you want to understand what some of those tokens are. And the important ones are things like entity detection. These are people, places, things. The next slide is going to look a little bit more in detail at entity detection. It is one of the systems that I personally was responsible for, so That's why it becomes my example to talk about. There's attribute tagging. Attributes are things which are not quite entities because they may not have identity, but they're things like dates, right? You're not going to have a different entity for every single date. There's an infinite number of dates. But you want to identify a date, and so we call those things attributes, right? Attributes are not only dates, they're also like numbers, currencies, and many other types of things. We also identify like parts of speech could be an attribute, things like that. Okay. Event detection. Once you've got all these basic pieces of analyzing text, you know what the entities are, you know some attributes, you can start to combine things and say that this sentence mentions an entity, mentions the word bankruptcy, and so you've got a bankruptcy event. Even further, you can know that it's a lawsuit. Let's say that Apple is suing Samsung, as they did a few years ago, and we not only know who is in the event, but what roles they play. We know who is the plaintiff, who is the defendant. Things that are really important when we talk about providing that data to the financial institutions. They want to not know just, this is a document that's relevant to Apple, but Apple is a plaintiff in a lawsuit. Samsung is a defendant. Right? Consolidation. This is one of the new things that we've done recently, where we start to look at all the events in the whole story body and realize that a headline might provide a summary of an event, and then in the story body, you're going to get some more details, right? So someone might announce fourth quarter earnings. The actual earnings figures are not in that headline, they're in the body. Do you want to publish that, hey, this story has an earnings event, and then it has an earnings up event, and then it has an earnings above expectations event? Probably not. You're giving people information, you're giving it to their computers, right? And computers are not smart. Humans are smart. A human reads a story, they know, it's earnings up and it was above expectations, and therefore, hey, the stock might go up. That's my business model, right? If you give a computer, here's earnings up, here's earnings expectations, and they might also say, but earnings across the whole year were down, the computer's going to get confused. So consolidation is the phase where we take all the individual events in a story and try and make sense of them so that they're easy to digest for a computer. Right? All of this works within the context of a streams-based system. Now, for those of you who are engineers, if you haven't worked with streams-based computing, it's really cool, and a lot of you probably have. It has to do with lazy processing and so on. It makes it really easy to start plugging new things into a system and making sure that your system uses resources like CPU really well. As I mentioned, low latency, 250 milliseconds or less per document is really important. So you need a system where you can start to say, okay, I want to add a new type of thing here. I want to also know, using the bag of words technique, how many positive words versus negative words. Plug that into the system. Does that depend on, what does that depend on? It depends on tokenization, great, but it doesn't depend on entity detection. So it can run in parallel. Things like this. A streams-based system allows that to happen, keeps all your CPUs busy, allows us to produce analytics really rapidly. So I mentioned I would go into entity detection a little bit more, as it's a system I'm very familiar with. There are a variety of techniques for entity detection. We use a dictionary-based approach. There are other approaches where you just look at a document and say, in English, these words are capitalized, it might be an entity, and look at other content. A dictionary-based approach means we take a dictionary of places, like GeoNames provides, hundreds of thousands of places, and we have our own editorial staff that is helping us to track more than 40,000 companies worldwide, organizations being things like governments and non-government organizations, also things like the United Nations, which are super government organizations, and so on. I mean, there's lots and lots of types of things there. People, currencies, teams, positions, products, commodities. I think I named most of them there. So one of the things that I think is very interesting about RavenPack's solution is that it's point-in-time aware. So what does that mean? We all know that companies change stock tickers and indeed change names over time. Certainly, they also change who their CEO is over time, things like that. So it's not enough just to track the entities, because an entity, IBM is IBM forever, right? But at some point in time, IBM made an acquisition. And so their acquisition, a small company I used to work for, Alpha Blocks, used to not be IBM, and then it became IBM. So detection of a news story talking about that needs to know, I find names in text, things that designate companies or designate other entities. To whom does it refer at the time when that was published? Most entity detection systems that I've looked at in academic research don't worry about that problem because they're more, well, let's say academic. But we've addressed that, and it's a really rich aspect of the system, and it's vitally important for the market that we're going after, financial traders. They really need to know when things like mergers and acquisitions occurred, what names are referring to what entities. The way things are detected can vary. Companies have things like tickers, right? But humans usually don't, right? Tickers often end up in the headlines with, NYSE colon something, things like that. People don't look that way. So the way the system detects various entities absolutely depends on the type of entity. You can also think about places. There's often pronouns. You talk about something happening in Malaga. Malaga is also the football team of Malaga, but you would never usually talk about in Malaga, talking about the team. It would be more about the place. So different types of entities, different types of rules. Relationships, I alluded to before about like CEOs at companies. This stuff is vitally important as well. Human names are particularly difficult. The next slide will highlight this. There's lots of people that share the same names. I'm lucky, Jason Cornez, to have a name that's not too common. I think there's a gentleman in Belgium that has the Facebook account, and that's not me. But other than that gentleman, I'm not aware of anyone else with my name. But our CEO is Armando Gonzalez, and that's a fairly common name globally. And there's many of them in Mexico, for example, and they are not the CEO of RavenPack. And when they're in the news, we want to make sure there's not a negative news event about RavenPack. Critically important. And so our editorial team maintains all the data about certainly the global companies in like the S&P 500 and major indexes in Europe and Asia. Who are the CEOs, who are the CTOs, the C-level positions, as well governments, who are the presidents of the G20, the top ministers, things like this. Again, this information changes over time. Really important when you're talking about identifying someone and getting it right. Because usually, especially the governments, the president of a country is often speaking not on behalf of himself, but on behalf of his country. Or the leader of a central bank talking about interest rates is not talking about his personal interest rates, talking about the interest rates of his country. You need to know this type of information. Stories are not without some metadata. They certainly have a timestamp. When did they arrive? We also generally know that this is a headline and this isn't. And a professional news provider like Dow Jones will often say from their editorial process that we think the following companies are in this story. They get that stuff wrong because they're not as sophisticated as we're trying to be. But we can use what they provided as hints to help us. So that if there's a story from Dow Jones and they say it's about Apple, it might not be. It might be about Microsoft really, and they're just using a template or something. But if Apple is in the story, it's probably not apple pie. It's probably Apple, the company. So those hints can help give confidence to detections. And the system tracks that as well. And of course, like any entity detection system, we've got an extensive database of stop words, things that you should not detect, like Apple. If you only see Apple and you have no other context, you really don't know what that is because it's a very tasty fruit. And equivalent terms are things like Inc., Incorporated, CO, and company, and so on and so on. So, sophisticated system. And finally, there's some colors here that didn't come out, but I can highlight what we're saying here. So as I said, many people share the same name, but they can hold positions at companies that change over time. We have that information, we can use it. People also have nationalities. Sometimes that can also change over time. And people have relationships to other people, either through marriage or through business or other things. So I'm sorry about the color highlighting not showing up, but this says Melanie Griffith. These are real headlines from the news. You probably recognize some of them. In this first story, Melanie Griffith is identified properly, and Banderas is identified as Antonio Banderas. The system gets that correct, knowing the time of the story and the related entities. Another headline that happened on a day very similar, I don't follow King of the Fighters, but if you do, I guess there's one of the top draws in that sport is some other gentleman with the name Banderas. And in that story, we do not detect Antonio Banderas, which is very good. Apple CEO Tim Cook attends the iPad Pro 9.7 launch. We get that this Tim Cook is the CEO of Apple. I mean, when you have this nice triple of company, title, and person, you're golden. I mean, it's hard to get that wrong. We also detected iPad Pro 9.7 as a product. That same day, there was actually a story about a football player at the University of, or at Oregon State, who had, I guess, sat out a year and was coming back, and his name is Tim Cook. And you really wouldn't want this to be something about an executive appointment at Oregon or something. That would be a really bad idea as an entity detection. So our system is aware of these things, gets this stuff right. Okay, so this is kind of where I'm going to end on what classification is. Classification is starting with a raw text document and providing useful information that can be consumed, in our case, primarily by the financial industry. Right? So now we know what classification is, and we're going to look at how we did real-time classification and then how we've used the cloud. So I hope the background was helpful. So RavenPack started like 13 years ago. I've been with the company the whole time. And 13 years ago, the cloud was not a feasible, real kind of thing that people were talking about. So we had to build our own business. We noticed that a lot of companies in the business that we're in were focused on selling software solutions. RavenPack from the start did not want to sell software. We wanted to provide a service. So without the cloud, this was kind of maybe the hard way of going about things for us internally, but it made it a product much easier to adopt by our clients. We don't have to do this enterprise software sale, go in, you buy your own hardware. And people that are veterans that kind of lived through software in the 90s and stuff like I did are familiar with that, and it's a really tough business model. So what we did is we set up our own rack at a co-location facility. It happens to be co-located right next to where Dow Jones News is produced, because we early on got a partnership with them and have had a product. Our first product was called Dow Jones News Analytics. And we got 6 servers. We learned all about KVM and set up a bunch of virtual machines. One of these servers was really much bigger than the others, and it runs a database. And it works great. But it has limited storage, multi-terabytes, but not petabytes for sure. And when we want to upgrade that, that's expensive, not only in terms of buying the hardware, but integrating it into the system. And the Dow Jones is located in New York. RavenPack is in sunny Marbella. So we usually have remote on hands, or we'd have to fly people out. A lot of us have lived through this, I'm sure, right? And there's lots of multiple points of failure. The database goes down, we're in really bad shape. Some of the others go down, we're in bad shape for a few hours until we can take an unused virtual machine, start things up on it and stuff. I mean, we didn't go through the process of building something like, Amazon's console where you click a button and you get a new machine, right? That's not the business that RavenPack's ever been in, right? Nor do we want to be. So when we migrated to the cloud, we got some benefits there, clearly. The system, more or less, starts with stuff coming from the outside into collectors. These are things that take any type of news, like Dow Jones or CNN website or Yahoo News, and convert it into a common standard format that we can use inside. So that by the time it gets to classification, we don't have to worry about the difference of where is the headline, where is the metadata. basic things like what are paragraphs. We can start tokenizing and so on at that level. That's what the classifiers are doing there. Okay? You see the big database in the middle? Everything kind of has to keep touching that. Right? Out of this comes a real-time feed, and at the same time, we also are producing historical archives. One of the key things that the financial community is interested in is definitely the real-time data. But before they're going to commit to that, they want to download archives of history. What have you guys said? What happened in the financial crisis of 2008? What was in the news? What did RavenPack say about the news during that time? So we can build a model that the next time there's a financial crisis, we can benefit from that because we'll know how things were done, right? And that's where the research comes into play as well. The research is on those same archives. So that's what comes out of the database into these snapshots. We'll find out a little bit later that there's not so much flexibility with these snapshots or with this feed. It's kind of a one-size-fits-all. Everyone gets the same set of stuff, and they kind of filter themselves. So this is how we ran for many, many years. We still have systems like this today. Okay, so we're moving to the cloud. RavenPack chose Amazon Web Services. We're really happy with Amazon. It's great. However, I'm sure that anything here could also work on the Google Cloud, on Rackspace, or if we were fans of Microsoft, on Azure. So now instead of having physical machines, we have a virtual stack, and Amazon has a service called CloudFormation that allows you to write in XML files a description of a set of hardware. And if you want another one of those, you say, take this description, click a button, and it will create the whole stack for you. That's a lot easier than spending $100,000 on hardware, flying people to New York, and so on. I mean, it's revolutionary. I mean, it just changes the game completely. Talk about redundancy before versus now. It's just very, very different. Storage. Probably everyone's a bit familiar with S3. For any company, it's essentially unlimited. I mean, it's like Netflix and Dropbox and all these companies are using Amazon and using S3 storage. So when we come and we say, okay, we want to put 300 million documents in something and this is multi-terabyte, they're like, we can deal with petabytes and petabytes, no problem. You want to double your archive? No problem. This is brilliant. It makes our business so much easier. And it's distributed with no single point of failure. It's not just like you have a bigger database, but US East has a problem. Well, it's okay. Your data is already replicated, already backed up. Your admin team doesn't need to know anything about it. Very, very clear benefits. Hopefully, any new business today is already using this model. Failover, redundancy, super easy. Let's look at how the model changed, though, the diagram now. We still have collectors and we still have classifiers, but now when we start to go to, instead of the centralized database, we actually are writing the data to a variety of different storage places. Those are DynamoDB, S3, and also Cloud Search, three different services, where it used to be everything kind of went to one relational database that kind of did all of those things. So we've had to increase complexity a little bit to get some of these benefits. As well, our classifiers now are sending data out to, ultimately, this database, Redshift, which is an amazing product. Lets you do OLAP queries without having to worry about indexes. If you ever had someone that just keeps trying to write ad hoc queries against your database, definitely want to look into technologies like Redshift. It's incredible. I mean, queries that took hours and hours now usually return in seconds. You don't have to worry about the indexes. So this is really great for the output of our data, the output of our system. That which we sell to clients, we can now internally and soon externally ask lots of questions about it. What were all the lawsuits Apple was involved in? And you can ask that against your standard relational database, and if you have the right indexes set up, it'll be fast. But then you ask a slightly different query, and who did they sue? Or something like this, things that you're like, oh, well, maybe I'll do a graph database, or maybe I'll do this or that. It all kind of works really well in Redshift. It's pretty impressive. And one of the things that makes it easy to adopt if you're thinking of going down this path is Redshift database looks just like a Postgres interface. You connect to it with a JDBC or ODBC, or Postgres native driver, and any of your client applications that talk to the database and can interrogate it will pretty much work. So it's really easy to use and adopt. That's not necessarily the case with all of these. The next slide goes into that. So this was great, right? I mean, we're on the cloud and everything's wonderful, okay? But RavenPack has spent kind of the last 2 years getting to the cloud. So what's going on? Well, when you get rid of your central relational database, if you choose to, you lose things like transactions. And if you grew up in a world with database transactions, you've learned to love them. They're amazing. They're really great and powerful. Now, you can run your own relational database system in the cloud. You can't just kind of take your stack and put it there. And then you don't get any of the benefits, except you can set up another one really quickly. But you don't get your distributed storage and things like that. So a lot of times you'll want to get rid of this database. Right? S3, like I mentioned, this infinite storage, you give it a key, it gives you a value. We give you a story ID, you give us the story. Fantastic. But it's not indexed at all. If you don't know the story ID, you only know, well, it happened in January, you're out of luck. S3 can't solve that problem for you. You can create directory structures based on time if you knew that, oh, I always want to look for things by time. But now let's say, okay, I built that structure. Now I want to find all the stories with Apple. Again, S3 doesn't help you. Okay? So you have to build your own index, and DynamoDB is a fantastic system for this. Okay? The problems with it, or why it's a bit challenging, one, that's not even listed here, is that it doesn't provide an ODBC, JDBC kind of native interface. You have to be a developer. You have to use an API to talk to your database. If you like SQL and have built database applications in that model, it is harder. I mean, your code might not be that much harder or more complex, but then your business person says, well, can you do this ad hoc query? Show me how many stories were in this month. Well, you have to write a program. A small one, a simple one, a Python script, whatever. But it's not the same. Your business users can't deal with it. So hopefully the folks at Amazon will start to address that and provide better interfaces. But things that I did mention here are you have to manage throughput. So how many puts and gets to the database? You provision that and you pay based on capacity provisioned. That's their model. So if you under provision, you're going to get, you're going to hit the threshold and get blocked. And if you overpay, then you're paying for more than you need, and it costs more. So managing costs is more up to you. When you own your relational database, you paid for it. There's no foreign keys or integrity constraints. Again, coming from the relational database world, you're losing a lot. You have to be aware of that. Eventual consistency. This goes with the kind of no transactions and so on. It's a distributed system. So I put something in DynamoDB and then I want to ask about it. It may or may not be there. Now, you can usually tune things, and with DynamoDB you can. You can tune it such that it is consistent now. But then there's a performance penalty. So you've got new knobs and dials. You probably spent, or I spent anyways, years learning all the knobs and dials on my relational system. And there's new ones here. And it takes some time to adjust to. Okay. Redshift, I mentioned, amazing for OLAP. But for online transactional processing, not good. Doesn't work so well. So they really want you to batch things up or micro batch anyways. And so they have some other technologies like Kinesis, which is a data bus. And you can put stuff in there as fast as you want, pretty much. You can add shards and things like that. And then you can have another application which simply waits per minute or per megabyte or per whatever you want and batch loads things into your database. Again, it's not that hard, but it is a different model than what we had before. Okay? And I'll say, as I think some other people have said, and it's certainly not unique to me, that the schema-free thing or no schema databases, this is a myth. It's a complete myth. Of course your data has a schema. How else could you use it? The problem is your database doesn't enforce it for you. Your database doesn't do anything for you. They sell this, of course, as a benefit. Add new columns whenever you want, add new properties, whatever you want to call them. And that is indeed powerful, and it is useful. There's no doubt about it. But the flip side of it is now your applications own the schema. Of course, your application has to know what properties are there. I mean, obviously, right? So I often say to my team that, applications come and go, but data is forever. And this is really true. Your version of your application today, you're going to write a second version someday. The data that's there, it's there. It has to be there. You have to know how to access it, what the schema is. Having the applications share the responsibility for knowing the schema is more work on you, the developer. Okay? You get this benefit of schema-free, add new properties, do whatever you want. Fantastic. There's a higher burden for you. It's part of the cost of migrating to such a system. So, applications more flexible, scalable, but there's more complexity, and it's real. The other use case that we have at RavenPack is historical classification. So when we come out with improvements in our entity detector, new types of events that we want to detect, well, we have this huge archive. We want to reclassify it, make that archive available to the clients, right? So in the classic thing, you've got the backside photo of that same rack of servers. And the important thing is it's the same rack of servers, okay? So when you do this huge job now, let's classify 300 million stories, you have to remember your hundreds of thousands of stories in real time have to keep going in real time. It's the same database. Oh, you're doing a backup this weekend? You better turn off your historical classification run. Backups are already very heavy. To do the full archive, and also, in terms of how many machines can you run to do classification, well, we've got this fixed set of 19 KVM things, right? So we could run about 4 to 6 classifier images in parallel during non-backup times, classify the whole archive, and spend about 6 weeks doing it. Now remember that at week 3, people start looking at some of the data that you've classified so far, and they realize that there's a problem. And Apple, the fruit, is being detected all the time as Apple company because someone introduced a bug. Restart. Now your 6 weeks is 9 weeks, right? This 6 weeks thing is the best case. And best cases don't happen so often in our industry, right? So the model here is really simple. Just the classifiers, read stuff from the database, write stuff to the database, and the output files, right? And this is what we can do. Things get much, much better now in the cloud. I'm happy to pay some of these costs, right? The servers are on demand. You want not just 4 to 6 servers, you want lots of servers, hundreds of them. Just ask for them. They're there. It's completely independent of the real-time system, and you don't have to worry about backups. For a business like ours, for any type of real-time business, this is crucial, that you can separate your real-time system from your historical or batch systems or anything else that you might be doing. And you don't have to buy twice the hardware to do it. You just rent it. We don't run historical runs all the time. We rent the hardware when we need it. It's a much better business model. So if we, as an example, use 100 classifiers, we can do this whole thing in 3 days. Or you can use 300 classifiers and do it in a day. It's much more powerful. The model looks a bit different too now. We have introduced this thing called a coordinator. People that are familiar with like MapReduce and stuff, this is going to look a little bit familiar. But I already described how our classification works, and it's not just kind of a matter of map this data into this filter and reduce it. The classification and what RavenPack's doing is pretty complex. We haven't figured out a way to kind of just say, oh, this is a function that Hadoop can call. It'd be nice, but it's a bit more sophisticated than what we can easily do there. So we've kind of built a similar system, but it's very straightforward. You've got a coordinator. You launch a bunch of workers. They're reading and writing from DynamoDB, the index, where are stories, S3, the stories themselves, and the results go out and ultimately end up in Amazon Redshift. Really, really big improvement here. This is great. This changes the way RavenPack does business internally. It really has. So now that we've got the cloud, we have some of the problems I talked about before about software development. But outside of software development, there's some other issues that I call the weather, since we're talking about the clouds. The weather is kind of what's your environment look like. If we have our own old system here, well, we've got pretty clear skies. We know what the resources are. We know who's using them. It's just us. We know exactly what workload. We know we do backups on Saturday nights or whatever, so we can work around that. And it's pretty stable. Actually, if you're running your own rack of hardware, it's probably a lot more stable than what you can expect out of any random machine in the Amazon, IBM, Microsoft Rackspace Cloud. They don't try to have machines that live forever. That's not their purpose. We buy very expensive hardware because we need it to live forever. We have full control. We start a service. We expect it to start very seldom and run for a really long time. We don't worry about the weather. It's not a concern. Now, one of the great things about a cloud is that you can bid for resources. You can either pay a fixed rate and get a resource now, or you can say, do you have underused capacity? I'd like to pay half of the given rate or a tenth of the given rate if you have machines that no one else is using. You can do that. Fantastic. You save money, you control costs. This is fantastic for jobs where a deadline is not so important. Historical classification that we do at RavenPack. If it's not done at 9 a.m. but done at noon, okay, that's fine. That hasn't changed our business. You have to be careful, though. You can actually bid for more than you would have to pay on the on-demand rate. So you can ask for a machine, and they'll give it to you, and that costs $1 an hour. But you can bid $2 an hour, and they'll happily let you pay that if you want to. So be careful. So we use this. But the weather really affects this. That's why it's under the weather slide here. Conditions are really uncertain. These are someone else's resources. They're shared. Your virtual machine isn't shared, but the physical hardware that it's on may be. The network connection of that physical machine, if it's gigabit Ethernet, and you've got a bunch of other people using that same gigabit Ethernet, you don't get a gigabit. You can't control that. It's unpredictable. And in the spot market, we have found so far that it's actually really easy to move the market. That means if you request 3 machines, you're probably fine. If you request 20 or 40 machines, your request moved the price significantly. You can't control this. And when someone else outbids you, which is, can happen easily if someone wants to, then your machine goes away. And you're usually given, they say, the best case is 2-minute notice. Right? And then your machine goes away. Gone. It's not there. So, how do we deal with this, right? So our conditions are uncertain, so you have to be prepared. You as the software developer, you as the organization, the operations team using these resources have to understand this. The first thing you can do is work in multiple zones. A zone is effectively probably a data center is what it maps to. I don't know, it's a virtual concept, but it's probably a data center. But it turns out the bidding prices are usually by zone. So if you do your work not in just a single zone, but in multiple zones, you can mitigate this problem of you moving the market price. Get fewer machines in each zone. Okay? Something really important now is optimizing image startup. So I mentioned this entity database, 400,000 entities, and so on. If we just start that image from scratch, it has to go to a relational database to find our database of what entities are there. What does the editorial team put in place? When the CEOs were at different companies and all this information. Of course, it's written down. That load time takes between 10 and 20 minutes. Now, if you're doing historical classification in the RavenPack system, that's on our servers, no problem. You start it once, it runs for 6 weeks, and you're done. Here, your machine goes down all the time. 10, 15-minute startup is unacceptable, so you optimize it. So that also means that your work has to be in well-defined chunks so that you can get a lot done quickly. And when you have your coordinator image, you don't want that going down at all. So you want to make sure you use something like on-demand there. So expect bad weather and be prepared for it. So that's the end of the kind of the use cases of the historical, real-time with classification. Huge benefits of the cloud, but some costs. Largely the costs are bared by the developers, by us. The cloud is also enabling us to do things that were really hard before. And one of these is self-service data. I mentioned briefly that everyone gets the same archive and everyone gets the same real-time stream. Because if you look at our single relational database and you want to now say, give me a custom slice of that and allow anyone to hit that, this starts to look dangerous. This database is used for a lot of things. You could replicate it by the cost of buying another one of those big things. Now you have to introduce data replication. It's a hard problem. The cloud does all of these things for you usually. They provide services. It helps. So RavenPack is going to be providing a web API so that you can request, I want this data set from this time to this time about Apple. And as well a web service, so you don't have to write programs, but you can go, and many of our clients will take advantage of the web service. More advanced ones can use the API. You can specify the data, the time range, the entities, the events, all the types of stuff I mentioned that kind of are in the data. Filter it. This is going to leverage Redshift and S3. Export the data from Redshift to S3. The cloud does that for you. You give it a query. It does it in parallel. It's very nice and fast. And then S3 is a place where you can give someone a URL. They can download a file. And the file is only what they want. So it opens up new possibilities for our business because of the technology decisions we make. Very nice. We can also now more easily support compression, multiple output formats, things that probably you could do before, but now, because you can easily just spawn up a machine to go and say, let's convert this huge CSV file to an Excel file or things like that, where you don't want to use that CPU on your dedicated system, that extra flexibility is great. And finally, the next thing that we're really thinking about doing here is imagining a cloud for our clients that offers RavenPack services. So Amazon provides a cloud that provides, machines, databases, things like that. And they provide higher level things like Kinesis for streaming and so on. Well, RavenPack has always been about providing a service, but what we provide now is public information, the news and so on. And a lot of our clients have said, we've got all this internal information, emails, Slack, research reports, and can you analyze that? But we don't want anybody else to see this. So back in the 90s, you say, okay, give us $1 million, we'll set up our hardware, we'll go to your place, you do this project, which lasts for 6 months, and then you did it, we're done. Okay, you own the hardware, your problem. It's almost a non-starter, right? Unless someone is really big and really motivated. But now, you can say, hey, I've got this stack that we use for our own real-time stuff. Boom, let's instantiate something. It's a virtual private cloud. RavenPack has access to it. You have access to it. Nobody else does. Upload the data that you want, process it, compare it. Compare it on the timeline with when public information was available. Combine those things. Look at what your information adds, how it adds value. When you're done, it goes away. Or they can say, we're done doing analysis. Can we keep the Redshift around? We want to keep running ad hoc queries. No problem. Costs are controlled. Resources are controlled. It's a new world. It's really amazing what's possible. So I hope that this gives an overview of what RavenPack's about, how we've migrated our business processes from a traditional rack-based model to the cloud, why it's super beneficial, what some of the costs were for us as developers, and if you're interested, we'll be happy to talk to you.
Is it cost prohibitive to, rather than bidding for shared use of a machine, to just have exclusive use of a machine for the company, or what was the motivation there to go for the bidding option?
Yeah, so the question is, can you, from your cloud provider, in our case Amazon, request dedicated access to possibly physical hardware, certainly virtual hardware? Yes, you can do this, and yes, it does cost a lot more. Some of the computers that we're using are approximately, somewhere under $1 an hour or something like that. Some of them can go up to $2 an hour. When you bid on them, you end up paying 20 or 30 cents or something. So when we looked at how much does it cost to compute our archive of 300 million, then if we do it in a really naive way, this can cost up to $10,000, $20,000 for a single run. Now, as we get to be a big, mature company, maybe that's no problem, but we're still a small company, and so that does become a problem. We don't want to do that too many times in a year. So it's an option, but for cost reasons, we and many other companies choose to go, pay a tenth of that. Thanks very much.